This video will be discussing ways to design multimedia instruction to minimize extraneous overload. Extraneous overload occurs when the essential cognitive processing and the extraneous cognitive processing are greater than the cognitive capacity of the learner. There are 5 principles used to design multimedia instruction to avoid extraneous overload. They are coherence, signaling, redundancy, spatial contiguity, and temporal contiguity. These principles are based on the cognitive theory of multimedia learning. We'll be going over 3 of those principles today: coherence, signaling, and spatial contiguity. The coherence principle states that learning is improved when the material that is not relevant to what is trying to be learned is excluded rather than included. The coherence principle is used when the essential processing and the extraneous processing is exceeding the cognitive capacity of the learner. It will be used to minimize the extraneous processing by eliminating material that is not relevant to the learner. This includes things like stories about the material, personal experiences with material, etc. This does not mean those things cannot be included. It just means that the instructor needs to be intentional about including those things, so they are at times when the essential processing is at a minimum, so the extraneous processing from the stories does not overload the cognitive capacity of the learners. The following images will show an example of where the coherence principle was applied and where it wasn't. Both these images will relate to the teaching of ideal mechanical advantage of levers. The first image here would not use the coherence principle because even though a seesaw is a type of lever, the image does not have anything to do with the ideal mechanical advantage of a lever. The second image here uses the coherence principle because again this is a picture of a lever, but this one has information relevant to finding the ideal mechanical advantage of a lever. The coherence principle directly relates to the cognitive theory of multimedia learning and the cognitive load theory. The ideas of essential processing and extraneous processing are analogous to the ideas of intrinsic load and extrinsic cognitive load from the cognitive load theory, and to the extraneous and essential processing from the cognitive theory of multimedia learning. The coherence principle also relates to the cognitive theory of multimedia learning because it discusses both verbal and graphical channels that can be overloaded when the essential processing and the extraneous processing are greater than cognitive capacity. The signaling principle states that people learn better when visual cues are added to highlight the material that is essential to learning. The signaling principle is again useful when the essential processing and the extraneous processing are greater than the cognitive capacity of the learner. The method for using the signaling principle is to simply use something like arrows or highlighting of relevant text or images. It is important that the signaling principle does not add any new information. The image here is an example of the signaling principle. The arrow is to point out a cirque formed by a glacier. This is a good example because it is highlighting something the learners are unlikely to already know. The signaling principle is related to the theory of multimedia learning and the cognitive load theory through the idea of essential processing or intrinsic load and extraneous processing or extrinsic load. Essential processing is managed by signaling, especially when there are lots of interacting elements, because it allows the learner to pay attention to what they should be paying attention to at any given time. Extraneous processing is minimized again by showing the learner what to focus on and avoiding the learner focusing on material not related to what is being learned. The principle of spatial contiguity is the idea that people learn better when words and the pictures that are related to them are near each other in presentations. The main goal of using spatial contiguity is to reduce the extraneous overload that is caused by layouts that are confusing or requiring processing to match words and pictures. So according to the spatial continuity principle, labels should occur within the diagram as opposed to a key or legend that appears off to the side of the image. When making use of images associated with words, be sure to minimize the distance a viewer needs to move their eyes to determine what the label refers to. The following two diagrams highlight the principle of spatial contiguity. The first image here has less extraneous processing because learners do not have to scan the page for relevant information. The next image shown here introduces extraneous processing because it forces the learner to scan the page for the relevant information. The spatial contiguity principle is related to both the cognitive theory of multimedia learning and to cognitive load theory, again through the idea of extraneous processing or extrinsic load. The goal of the principle is to reduce the effort required to scan the page or presentation, which would count as extraneous processing.